So this is just a quick review for geometric sequences. We want to define what a geometric sequence is, represent the geometric sequences, and apply it to both simple interest and population problem. So first is the definition of a geometric sequence. A geometric sequence is formed by constant multiplication. This is in contrast to our arithmetic sequences that were formed by constant addition. So a sequence formed by multiplication of previous terms. So for example, using our notation, we could start with some term 2 and have a recurrence relationship that says the next term is going to be this previous term times, let me say, 2. If we look at this as a table of values, now we have 0, 1, 2, 3. Let's look at the first 5 terms. A sub 0 is 2. Times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Just like before, while we have a recursive definition, we want to be able to represent this in closed form. And here, what we should recognize is that we start with a value of 2, and we are constantly multiplying it by subsequent powers of 2. So 4 is 2 times 2. 8 is 2 times 2 times 2. 16 is 2 times 2 to the third. And 32 is 2 times 2 to the fourth. So what we have is we have our first value, our starting value, 2, and it's being constantly multiplied by 2's. So we have this relationship. In the compound interest example, we may have an interest rate of, let's say, 3%, 3% a month, and we could start with $100. Then we could figure out the amount in the account in any given month, because we would just be multiplying 100 by 1.03 to the n. And again, this comes from that first we would find 3% of 100. We would do 100 times 0.03, and then we would add that to the amount that we have in the account. We can factor that 100 out, and we can look at this as 1 plus 0.03, and so we would have 100 times 1.03. This is another way to say of adding 3% to 100, and this will happen n times depending on the given month, just like we have here.